Hello again. You must have seen racing bar graph or while various data visualization projects, you must have seen some of those animated bar graph or pie graph or some other 3D graphs which are animated. They have lots of data built into, and using the animated time series visualization, you could see how the data changes by the time. After watching those graphs, you must have thought, what if I could do the same? And if that is what your objective is, this tutorial is for you. In this tutorial, I have used few different examples, use pre-built race bar graph libraries as well as the animated functionality available within the Matplotlib to animate few bar and pie graph. I also went little deep inside the code to make you understand what is really needed for you to convert your data frame or data set in a way that can be used to animate your data. So let's get started. In front of you, the Jupyter notebooks we are going to use in this tutorial are already available at public code repo. You can clone this repo and get these notebooks and play with the code. Please make sure you have all the libraries and required modules installed in your machine to make sure all the notebooks works on your environment. So let's see very first Jupyter notebook. Here, as you could see, these are the three notebooks I have, and very first thing I will show you one pre-created notebook which I found on GitHub. So I'm just using that notebook as it is. You can get this notebook directly from this location if you are interested, and there is a Medium article also available by this article writer, and you can learn a lot from there. As you could see, I'm importing few methods from Matplotlib and NumPy library. Next thing, generating some of the numeric data so a sine wave can be created, and a sine wave data is being plotted using Matplotlib library. This is very important. The func animation methods are imported from Matplotlib animation module. In the next step, we are going to use the Matplotlib interactiveness plotting methods to create the animated graph. First cell here, we are enabling the interactive plotting within the Matplotlib. Next, we are importing this very important method, func animation, from Matplotlib animation module. If you are getting error in this step, make sure you have the latest Matplotlib library installed with your Python runtime environment. If you will not have latest Matplotlib library, you might not be able to use this function. In the next step, as you could see, we are using Matplotlib subplots method to create these two objects, and this AX object, it use to render the plot, and the numpy.syn method is used to generate the sine wave data. As you could see here, this func animation method, which is part of interactive Matplotlib, and that method is called here with number of frames, the animation interval, and this method is calling this function, where this function is being called, and depending on the frame counter, the sine wave data is generated, and that is rendered in this fig, which is the Matplotlib subplot object. So this func animation is the main method here, which does all that work, and the result of this func animation method are stored on anim object, and that object is what can be used later to save this animation data. But initially, once this fig object, which is part of Matplotlib subplot, that plot is animated plot is visible with this matplotlib.show method. So let's start this. And as you could see here very quickly, with this Matplotlib interactive enablement, we could see this sine wave is working. It's a very simple way and very quick way you could generate the animated graphs. Now the animation is created using the embedded HTML5 video. And in order to have that video, you must have FFmpeg library available in your local file system so it can be used. Here in my machine, I already have that library available in this path. And just to make sure I do have that path available, I will open cell and I will make sure that we verify it. At this point, you can see that this particular file is available in my file system, and that's why I am using it. So very first thing, if your objective is to create the animation using embedded HTML5 video, make sure you download this library. And to download this, I already have this URL ffmpeg.org, and depending on your operating system type, you can download those binary required for you. Once you have that, make sure your environment is set and required modules are loaded. As you could see, everything looks fine here. In the next step, as you can see here, the code is almost identical. There is not too much changes in this code here we have. As you could see here, the next option is that we are using any ANIM or animation object where the func animation results are stored, and using this animation and trying to render it to HTML5 video. Rest of the code is exactly the same here at this point. So if we take this and we try to use this anim object and run it, as you could see here that it is still using this animation data which is here, and we are just rendering that data here. If you would want to make it slow or fast, there are a couple of things can be done, and at this point I will be using this method. So you could see the differences here. I could say interval is 100, restart this, and interval is slow down here. If you want super fast interval, now we have done this, this will be quite faster here. If you would want this plot to be big, you can make it bigger by changing this subplot area, and here you could define the size what you would want. If your objective is that do not repeat this animation, you could use this repeat equals false. And if you set this way and if you run here, depending on its interval timing, it will stop here. You run here and it will stop. So repetition is not there, but if you make it true, it will be keep. It's a pre-built Jupyter notebook written by some other gentleman. I just wanted to show you that very quickly how you could use Matplotlib interactive plotting or the embedded HTML5 video component to build the animated graph. If you want to save them, you have option to save either MP4 or save the GIF file. These things can be stopped too, and if you look here, you could see that sinewave.gif and sinewave.mp4 file is available. Here is the sinewave, and I could play here, and that's the graph you could see. If you are interested in seeing the GIF file, that is also available, and that is where all the frames with that GIF. So these are the examples for you if you would want to save the content from HTML5 component. Next, we are going to use the another Jupyter notebook. Here I have created a new example to create the pie chart, and we are using same FFmpeg library and HTML5 components to create the pie graph demo. Very first thing, we are importing the required methods from Matplotlib modules. Now let's import the modules. Download the FFmpeg module. Here I just wanted to show you a little issue you might see if you are using OS X operating system and using the FFmpeg library from some other location than user local bin ffmpeg. Here you could see that I have the ffmpeg modules available in a different location, and I'm using that from this location rather than user local bin. Okay, we are using the display modules from IPython. Here just defining few numbers. So here you could see it's the array of numbers. So here are 5 numbers which are related with these 5 labels. I could make it much more easier to understand. So I have 5 different objects or fruits, and these are the numbers for each one in iterative method. So this is an array of array where the sequence of these numbers or the total number of fruits are available. And here is the color type. Once we have loaded the number, now we are importing the NumPy library. And as you could see here that these numbers, so there are 10 rows and each row is the shape of 5 items. That's our numbers object. Next step, we are creating this update method, and this update method actually does is that it's try to render these numbers in sequential form. It just reads 1, 2, 3, 4, 5. That number is index which is used, and as you could see here that using index, using this AX object, which is again the Matplotlib library subplot method. Here is the size of this graph we are creating, and using the ax.py method to pass the numbers related with graph and explode. Labels are the labels related with our pie chart, colors for that pie chart, the automated percent setup, shadow relate all those graphs is through. Start angle is about 140 degree. Explode means that if you would want to move a certain pie outside, that you could use by this number. So here you could see that we are using 0.1 and 0.05, and the impact you will see for the orange or blue color pie, that little extracted outside or designed in little differently than other whole pie. Run this thing. Update method is already being instantiated. Next step is to call this functionalities method where we are using fig. We already know that this is part of Matplotlib plotting library. Update is a method we are calling, and here is our number of frames, interval, and repeat equals true. The animation object, next animation object, is used to call to HTML5 video. And this is what here you could see that because in our example we are using the ffmpeg library from tools ffmpeg location, and OSX is not making it run. So there are a couple of options you could do. One is that you could make sure that this particular library is ready to run. Second, you also need to make sure that you have security enablement to make this ffmpeg library to run. Here I have an example that how you could solve this problem. When this dialog box is open, visit to security and privacy at your OSX settings, and here you could see that ffmpeg was blocked. You unlock it and you allow it. Once you allow it, then this ffmpeg specific error will go away and you will be able to use it. So that's one option you have. Second option you have is to change the path. This path you do not use it, and instead you could move this ffmpeg to user local bin and use this path. And once you have this path and you would write to use this, the error will go away, and as you could see here that animated pie graph is created. As you could see, it's using 10 frames, and because there is a range is 10, so it's using that. Interval is a little slow, is about a second, and these numbers are being updated every second. Here you could see that orange, which is the orange here. So we do not have orange, so I think we could make orange as an orange color. So let's make the color is orange. We have color, we need to call the labels. This has to be updated, and at this point let's update this here, and this is the orange color. And as you could see here that this is more extracted. The banana, which is green, exploded value is 0.5. So it's like almost double between orange and banana. Rest of the explode values are 0. And that's why these three are intacted within the pie graph, but these two are little exploded. If you want to save, it's the same method. You could use the GIF. If you want to use a writer, some other or specific, you could define it below. If you will not pass it, it will use the default writer. And next, here you could see that the MP4 can also be created. If you want to save the GIF file with a different frame per second method, you could control it that way as well. So in this example, you have seen how you could use the HTML5 MP4 playback method to generate an animated pie graph. So that was our second example. And in the number 3 example, we are going to look this bar chart race module, which already has everything required for us to build the racing bar chart or race bar chart. You could install it. I do have the tutorial available for this bar chart race, so you can use that documentation. As you could see here, whole documentation is available for you to learn how to apply that for your objective. So I will be quickly showing you this. Make sure you have that available. Here I'm importing the bar chart race, and I'm also importing the Pandas library. Next, I'm just showing you that bar chart race is already installed in my machine, and that's the version 0.1.0. Next, I am reading this urbanpop.csv data. The data looks like that way. Here you could see that it has the 0 base index, year number, and then depending on year, here you could see these are the population for every country, depend on which year, and as this population is growing for these countries. To know more about this data frame, we could understand that, okay, how many rows and how many columns are there. You could say df.shape. We have 43 year worth of data until 2018 for the 38 countries. Next, as you could see here, we do not have the index set because of 0 index based data. So we are going to set the index year, and as you could see, the year value is set as an index. In the next step, we want to build the bar chart graphs. So index is set. As you could see, there is index here, and rest of these values related with individual column. And the title is by population growth for our bar chart race, and we are creating a very quick graph here. This graph is using this data frame, which we have already ingested, and make sure that our index is set. As you could see here, this graph is created with most of these rows pre-populated. As you could see here, we have about 37 columns. It's a horizontal graph where these numbers are rendered horizontally for each column, and it looks like that all those columns, almost everything is pre-populated, and the data is started with the racing bar graph. As if you could see here that the 21 second time frame is given for this graph to run complete, and after that it will try to restart again. So we will pause it because we do not need to make it run again. Next, we are using the same data frame, but we are making sure that start only with the 10 bar and keep adding as needed, and make the horizontal orientation fixed order, and C map is prism. So color map is prism. And let's see how this visualization look like. As you could see here, the bar graph started with horizontal orientation and about 10 bars to start with. Because of the number of bars is set to 10, only the top 10 values will be used. As you could see here that with this total number of bars 10, we do not see some changes. So I decided to make this graph little different, made this orientation vertical, and added the 15 bars to it. Rest of the settings are same. Here you could see that the 15 values we see the data is started with, and new columns are being added. Some changes are available. That's all I wanted to show you with this pre-built library. If you want to save this bar chart data frame, make sure that you are using the same data frame, and you could save that data to the disk, and after some time this population.mp4 library will be created with this desired plotting size, which you could share with others and play offline. Here you can see this population mp4 is just created just to verify that method save does work. After this example, we have another example, which is a little different example where we are using the COVID-19 cases data for different countries, trying to process it in a way so that it is applicable to this bar chart race library. First, we are setting up this URL. You can use this URL and go to GitHub to get this content. We are reading this data frame in this df COVID data frame with the headers. As you could see here, we are selecting at this point. We can take a look this data frame. As you could see, it has 228 rows and 741 columns. So columns has these different date where the number of reported COVID cases for each country all the way from this date to the 21st January 2022 up from 21st January 2020. It's about 2 year worth of data. Here we are creating a selected data frame, and this selected data frame should give you the idea that what we are selecting here, we are selecting 4 different countries worth of data, but we are selecting all the dates from start to finish the data frame. In this next step, we are creating the filtered data frame. We are using the transpose method, and we are selecting only 4 countries we are interested into. So we are transposing our data frame in a way that it's applicable to the racing bar graph library. As you could see here, we have data as these values. Index is not set. So as you could see here, the index is not set here. So we are setting the index. We also figure it out. These are the index, and as you could see, that index type is object. It means these values are read as a string. So we need to convert them to the date time. So we are converting this filtered index to the date time, and now you could see here that our index values are converted to the date time. As you could see here, the value of filtered Germany is integer 64, and in order to make that library working bar racing graph, we need to make sure that all those values are converted to float. So here all these 4 columns, I am converting them to the float. Now each column, what we have seen here is changed. As you could see here, they were all integer, 64-bit integer. After that, our data frame is ready to be consumed with bar chart race. Here we are using this df filter data frame to be applicable to bar chart race library, where we are using ascending sorted method and the title. As you could see, we have seen this graph. The numbers are really very high. So it's about 6-minute long graph. But this graph is designed for 4 countries only. So you will not see more data here, but at least you can get an idea about how we could use a data set and transform it in a way so that it's applicable to this racing bar graph library. I will stop it. Next, if you are using this or bar race graph library, it comes with a COVID-19 tutorial dataset. Here in this example, we are loading a default dataset. It's a 1010 size. This is a data really look like. Everything is preset. As you could see here, everything is set. So you could see that it's of all the data here, float type. Index is already preset, and if you would want to see the graph very quickly, you could run it and you can see this default value. If you are interested to learn more about it, there is a lot in this library. You could use this documentation and you can make your graph much more impressive depending on your need. Before I go, I just wanted to reiterate that all these 3 Jupyter notebooks are already available at GitHub, so please use them and play with it. So in this tutorial, we have used the pre-built Python library to build the race bar graph. We have also used the animated methods or functionality available within the Matplotlib Python library to build either bar or pie graph and animate them. We have also learned how to process your data set or data frame in a way that it's ready to be used for animated graphs or animate the data within your data frame or data sets so that you could create animated data visualization. I hope you have enjoyed the tutorial, and I will see you in my next tutorial. That's all, my friends. If you have enjoyed our content, please like it, share it, subscribe it. And finally, please remember, be good and do good. Thank you.